Okay, I was asked to speak about, this is a science class, to talk about science and Kashrus, how they interact with each other. And I'm going to talk to you about things that have to do with chemistry, biology, physics. Okay, and before I actually get into the examples, there are lots of things that are not kosher, but are actually fewer than you might think. We're going to focus on three of them right now. Okay? And the three of them are meat that didn't have shrita. Okay, like you walk into a Costco and there's a piece of meat there, didn't have shrita to it. That's not kosher. Grape juice or wine that was made by someone who's not Jewish, and it was touched or moved by someone who's not Jewish, that's called stam yain, that's not kosher. And chametz on Pesach is also essentially not kosher. We can't eat it on Pesach. Okay? So all those things you obviously wouldn't eat. You're not going to walk into Walmart and buy a hamburger there, right? You're not going to buy grape juice that didn't have hashgacha. Okay? Those are obvious that those things you're not going to have. But I'm going to talk to you today, time permitting, is how that ends up affecting vaping juice, or medicine, or flavors, or all kinds of some other things that are affected by those things. You say, how does medicine have anything to do with grape juice? What's the connection between them? And I'm going to try to show you that connection and how the science bring those together. And then, again, time permitting, we'll do some things that are, some other things where physics of food plays a role in things to do with Hilchos Shabbos and how we kasher things also. Okay, so the first is like this. Animal fat and oil are made have exactly the same structure. Okay, this is what animal fat or oil looks like. Okay, it has something like this. Okay, in that kind of a shape. Okay, we call that glycerin. Okay, and then we got on each one of these pieces that are sticking out is something like this. Okay, and those orange ones, those are fatty acids. Okay, what they are and what exactly that means is not so important to us. Okay, what it means is like this. But if every fat and every oil looks exactly the same, so chicken fat and olive oil and cottonseed oil, they all look the same. The difference between one and the next is the orange parts. Okay, the glycerin is always the same. The orange part, the fatty acids, it's different. And depending on which fatty acids are on there, it depends on what it's going to be like. Is it going to be like animal fat, or is it going to be like olive oil? Okay. Now, if you put fat or oil into a device, it has a really simple name. It's called a splitter. Okay? The splitter is like 100 feet tall and like 10, 15 feet across. Okay. It goes at like 700 degrees. And if you put the oil or fat into it, this gets split in half. You get the glycerin goes one way, the fatty acids go the other way. So, whatever you put into it makes no difference. All kinds of fats or oil you put into that, that's what comes out. You put in coconut oil, it splits the glycerin into one half and the fatty acids into a different part. So, the glycerin part, which is what we're talking about right now, the glycerin part that comes out of there is the same whether it came from animal fat or vegetable oil. Okay, it's the same thing. The only difference between one and the next is the fatty acids out of there, but the glycerin is exactly the same. Now, glycerin has a sweet taste to it. Okay, even the oil doesn't taste sweet, but glycerin tastes sweet, and it has all kinds of other properties that make it really useful for kinds of things like vaping juice. Okay, you can't pull it out now because the teacher's here. But if you look at a vape juice later on, you're going to see that it has glycerin. Almost every one of them has glycerin in it. Okay, so that glycerin could, if it came from animal fat, it would be obviously not kosher. The animal didn't have shrita. That animal, it would be not kosher. Even if it was made with vegetable oil, it also might be not kosher. And that's because this splitter that's there could use both. You could do both. There's other purifications that also take heat to them that could be used for animal and vegetable also. So the reason why it would need hashgacha is because the glycerin part of it could be from animal, could be from vegetable, and we have no way of knowing. That's what hashgacha is for. Hashgacha would make sure that the glycerin you're getting is coming from a kosher source. Okay, now, what happens to the fatty acids? When they make this splitting, the way I'm talking, it makes it sound like the glycerin is the main part. It's really not true. The main reason why they want to split it is because they want the fatty acids. So, as I told you, fat or oils have different fatty acids. And they have all kinds of properties that people who make food want. They want those fatty acids for all kinds of purposes. Some fatty acids come from animals, some come from vegetable, and some can come from either one of them. So, the splitter After the splitter split it up, we take this mixture of fatty acids. It's a whole mix of fatty acids, and we put it into something called the distillation column. Okay, anybody here know what distillation is? You might have heard that term. Yes? What do you say?
It's to purify something, usually by putting it through a few filters.
Okay, well, you're close. Not through filters. What's the way you separate things in distillation? What?
It's not like boiling.
It's through boiling, and what you do is like this. Different things boil at different temperatures. Okay, so like for example, this distillation that most people are familiar with is to make whiskey. When you want to make whiskey, you make something that has just a small amount of alcohol, and then you distill the alcohol out. And the idea is you want to make something even more alcohol. So when you originally make it has like 12, 13% alcohol. When you distill it, it becomes 40, 50% alcohol, which is what people want when they want to drink whiskey. Okay, how do you get the alcohol out of the rest of the stuff that's there? The answer is alcohol boils at 173 degrees. Water boils at 212 degrees. So what happens if I heat this liquid up to 180 degrees? What's going to happen is the alcohol is going to boil out. The rest of it's going to stay behind because the water didn't boil yet. So the alcohol will boil out. That's how distillation works. You bring it to a boiling point that one goes out and the other one stays behind. Okay? Am I getting too complicated? Okay. So in the fatty acids, they do the same thing. But there, it's much more subtle, the difference between one boiling point and the next. So for the fatty acids, they put it through a still. Okay? So we put it through a still. This is physics over here. We put it through a still at exactly the right temperatures to separate out the stearic acid from the, palmitic acid. Okay, we put one fatty acid gets distilled out of the other one to get them to exactly the ones that we want to. And then one of the uses for fatty acids is to make flavors. One of the things that you use the fatty acids for is for flavors. Like for example, stearic acid could be used. I then went to look at companies that we give hashgacha to see what they do with different fatty acids. So one company that we give hashgacha to makes a flavor. It's a butter flavor. It's parav. It's a butter flavor. And stearic acid is part of what makes it taste like butter that's in there. So stearic acid, the word steer is like from like a cow, a bull. Steer is another form of we'll call it a cow, just for lack of a better way to say it. What?
Why wouldn't that make it flavors?
It would make it treif, because the stearic acid, if it came from an animal, it didn't have shechita to it. No. So if our company who's making this butter flavor is making it from stearic acid, not from an animal. They're making that stearic acid from a vegetable oil that they have to make sure. That's what we're doing to make sure that they use the right stearic acid and not the wrong one. Hold 1 second. Okay, or another company who's making ethyl stearate. So they're taking stearic acid, reacting with ethyl alcohol, whatever that is, and they're making rum flavor out of that. Okay, so the point is, the fatty acids that come out of the fat of the oil, those turn into flavors. That's also in your vape juice. It's in lots of other things. Okay, they have flavors in them. The flavors got all kinds of chemicals that give it a certain taste to it that make it taste like whatever they're trying to make it taste like. Okay, again, you want to make it taste like rum, so you put in X, Y, and Z, and you want it to be cherry or banana, whatever you want. You put in the right things. Not everything comes from fatty acids, but fatty acids play a big role in making flavors, and that's why flavors need hashgacha. Because they could come from anything. I showed you one group of places they could come from, which is straight from animal fat, or from vegetable, or maybe with animal fat. Okay, yes, you had a question.
If you would take it from a kosher cow, like a cow that was shafted, would it be fleishiks?
Yes, it would be fleishiks. Yeah, but that would be so unusual and strange that from my perspective, anything that comes from animal is not kosher. The only thing that comes from animals that are kosher are things that you buy specifically from people. Which is to say, if you want to buy potato chips, there's lots of potato chips out there that are kosher that are not specifically marketed to from people. Because it doesn't cost them more to make kosher potato chips. They have to be careful how they do, but they can make it, and it can sell to everybody. You can't sell hamburgers for the same price as non-kosher hamburgers. There's so much involved in making kosher meat that all meat is not kosher unless it's specially made for people who keep kosher. Okay. Any questions before I move on to the next thing? Okay. Anybody can know what glucose is? Yes. Sugar, yes. We'll use the word sugar. It's easier to say the word sugar. That's not a technical word. But we'll use the word sugar instead of the word glucose. The glucose is a sugar. Now, how do you get sugar? How do you get sugar?
Plants.
What do you say?
Sugar cane.
Yes. So in South America, it comes from sugar cane. If you want actual sugar, that's a good chance you get it from sugar cane or from sugar beets. Okay, that's what you would get it from. But in the industry, what I'm going to be talking to you about now, they want actually glucose. Okay, so they could get it from there. In South America, that's where actually they would get the glucose from. If they were getting it in France, New Zealand, where they have a lot of, sometimes they end up with years with extra grape juice, extra wine. They could take the extra grape juice that they had and take the sugars out of that. The grape juice is really sweet. They get the sugar out of that. Okay, that would be stam yayin. Okay, so that would taste like sugar, but it would be made from wine, which would be not kosher. It's stam yayin. Okay, but most of the world doesn't do either of those things. Most of the world makes it out of starch. Okay? How do you make sugar or glucose out of starch? Okay, what starch? Think about starches like potatoes and rice and sweet potatoes and wheat. How did those things become sugar? Any ideas? Okay, so the answer is like this. Starch is really made up of hundreds of sugars, of glucose, or other sugar molecules attached to each other. Long strings, like it's drawn on the board here. Right? Long strings, and all kinds of branches and all kinds of things. Long strings of sugars attached to each other. And they have a bland taste to them. When you break it apart into individual pieces, you break it apart into individual sugars, all of a sudden it tastes sweet. Like, for example, you've all tasted corn syrup, right? Like you buy a drink and it has corn syrup in it. That's made from corn. Corn doesn't taste that sweet. But if you take the corn, which has this really long chain of sugars to it, and you break it down into individual ones, you make it taste sweet. Okay, and actually they do a trick. They turn it into high fructose corn syrup, but the same idea. They make it into the short molecule, and it tastes really sweet. Okay, so in most of the world, they make the glucose out of some kind of starch. So sometimes glucose is going to be completely kosher, no questions at all about it. Sometimes it's going to be stam yayin, if they made it from wine. Sometimes it's going to be chametz. Okay, it's pretty common that it could be chametz. If for sure it could be kidneys, but it also could be chametz. Okay, why am I telling you all this? Why do you care about glucose? Which one of you ever going to see glucose? The answer is like this. There are all kinds of things called the microorganisms, like bacteria and molds and funguses, all kinds of microorganisms, these little things that you can't see. And all types of them make all kinds of things that people want. Either because they know how to do it themselves, that's what they do, they make xanthan gum, or they make citric acid, that's what they do, or they get reprogrammed. Okay, microbiology reprograms the mold to make something that it wasn't supposed to make. This mold is supposed to do this, they say, okay, thank you very much, we need you to do something else. Okay, and they reprogram him to do something else. Okay, this yeast that used to do that now does something else. Okay, so this little microorganism will make something that you want. Like xanthan gum, I mentioned, xanthan gum is a thickener. It's used a lot in medicines. Okay, and you want to make something that's very watery thick, put xanthan gum into it. You want to wash vegetables, like cut up vegetables, if you see like a bag of lettuce or something like that, you want to wash it in water with citric acid. Citric acid comes through some microorganism who makes it. Okay, well, you have this microorganism that's willing, so to speak, to make xanthan gum for you or to make citric acid. Then you put it into a big vat full of glucose. And he's really happy to eat sugar, just like you would be. Okay, he's putting it into a big swimming pool full of glucose, and it's a party. Okay, he's supported. He's got all the glucose that he needs. He's got everything that he needs. And you come back tomorrow, and instead of having a big vat full of glucose, instead you have a big vat full of xanthan gum, citric acid, whatever the things that you wanted to make out of that thing. That thing is now chametz or stam yayin or whatever it is, depending on what you made it from. Okay, so we put a big vat full of chametz. Remember, we took wheat and we turned it into glucose, and now tomorrow turn it into xanthan gum, and it would be usher to eat on Pesach. Or it would be usher because it would be stam yayin, it wouldn't be kosher. Yes?
Why is it that milk comes from a cow, but it's milchiks, and yet it's a derivative of a behemoth? But here we have a derivative of chametz, which is still being held to the same standard as the chametz. Why is it not changing distinctions? Because it's no longer chametz, it's now a new entity. It's the xanthan gum, it's the citric acid, it's whatever it is. So why is it still being categorized as part of that original source?
Okay, it's a good question. So the question is, how come when something comes from something that's usher, we treat it like usher, as opposed to milk comes out of a cow, we don't treat it like a cow, we treat it like something different. Okay, so the answer is the Gemara says it's like not obvious. It wouldn't be obvious to us. The Gemara says this a liba to teach us that yotzim and tame is tame. Something that comes out of something that's not kosher is not kosher also. So if let's say if a horse gives us milk, okay, the milk that comes out of that horse is not kosher. It came from something that was not kosher, it's not kosher. Okay, if we have a bug that gives us some excretion, the excretion that comes out is not kosher also. However, what? Speed is an exception to the exception. And an exception to that, it's an unusual.
It carries it.
So that's a machlokes in the Gemara. Yes, two words in the Gemara. One teretz in the Gemara is that he doesn't excrete it. It's not an excretion. The other Gemara said it is. Do you know what that depends on? Well, because the bee doesn't actually just carry it, right? The bee puts some saliva into it. That turns it correct. An enzyme in it.
Then why is shellac?
So it's a machlokes.
Then why is shellac kosher if you substitute this?
Hold your second. Let me answer his question first, and I'll get to you in a second. Okay? I'll get to you in a second. That's a good question also. But the reason why milk is different, you know why milk is different? Because it's what he says. You can't eat milk with meat. Milk coming out of a cow really has the same status as the cow. It's true. If it comes from a horse, it's treif. The Torah says that thing that came out of a cow, you can't eat it with the cow. That's what the Torah said. Don't eat milk with meat. In fact, it has the same status as the cow, but it's got this extra rule. Okay, it's like why do we shake a lulav on sukkahs? Because Hashem said so. That's what he said. So he said, don't eat this milk with the cow. So it's lazain. That's what we don't. We don't go with cow. Now, shellac is a whole different story. Okay, shellac is the reason why it should be asur also. Shellac comes from a bug, right? So you wonder why shouldn't it be asur? So the reason is because this is something that's not inherently asur. It's also because it came from something that was asur. So the rule is like this. When we look at something that came out of something that was asur, we have to decide if it was edible at the time it left. So when milk comes out of a cow, it's edible right away. So it's asur. Okay, honey comes out of a bee, it would be asur also, except for the special rule that it's not. When shellac comes out of a bug, it's called a lac bug, that's what it comes out of, it's not edible. Okay, then it's used for furniture polish. Literally, that's what it's used for. Okay, but if we play around with it, if we put a really thin amount of it that you wouldn't even notice, then you can put it onto your candies and this and that. So that's the reason why we consider it asur. Some people don't. Some people consider it asur. But the reason why the national hashgacha is considered to be mutter is because of that. When it leaves the bug, that's the time you have to decide, is it coming from asur or not? At that time, it was not edible. Okay, so that's the decision point.
If you would put it if at that time when it's coming out, you would put it in thin layer, it's still not edible?
It's probably still not edible. There's a question. Maybe if I put so little of it, you wouldn't notice it. So it's hard. Is that considered edible, or that's because you just didn't even notice it? You just didn't notice it, right? Because there are candies that have Shabbos candies like wax on them. Also, that is really not edible. Okay, it's a fair question. Yes.
About gelatin.
What about gelatin?
How the gelatin that is used in most kosher candies that is from cows or is it from animals?
Sometimes from fish. Sometimes it comes from kosher fish. That's the easier way to make it. It's not as good as the kosher animals. When they make it from kosher animals, it's animals that have shechita. They're kosher, so they're kosher animals.
How exactly is it made?
How's it made? It's an extraction from the bones. Okay, we're getting off topic. Let's go one more. We have one more thing. Wait, we have one more thing to see before recess, and then we'll decide if you guys want to ask questions or not. Okay. Now we're moving away from the chemistry, biology mixed with physics to something that's plain physics, and that's like this. Most people know. I already even mentioned it a few minutes ago that water boils at 212. Okay, but you might also know that that's only how water boils in irregular atmospheric pressure. If we go to Mr. Fleischer, we go to his house in Denver, okay, water doesn't boil at 212 there. Because there's a vacuum, okay, there's less air pressure, whatever that means, there's less air pressure, and water boils there at 203 degrees. Okay, so if you want to cook something in Denver, it takes longer, the instructions are going to take longer. If it says in the instructions cook for 10 minutes, then over there you cook it for longer. Excuse me? Higher elevation. But higher elevation, there's less pressure, less atmospheric pressure, and therefore it takes longer to cook it. Okay, it takes longer to cook the same food than it would to cook it here in Chicago. Wait, if you go to Eretz Yisrael and you go to the Yam HaMelech, which is the lowest point on Earth, okay, has the most atmospheric pressure, there water boils at 214 degrees. Okay, not at 212 degrees. Okay, so the boiling point has to do with the atmospheric pressure. Or anybody here's home has a Instant Pot? An Instant Pot? You have one? And what happens in an Instant Pot? It pressurizes the food and it cooks faster because it gets to a higher temperature. You could put the spaghetti in there the chalk in there, it's going to cook faster because it gets to a higher temperature without boiling out. Okay, it cooks faster. Okay, so sometimes in the factories, too complicated to explain why, but sometimes in factories, it's kedai for them, it's worthwhile for them to cook in a vacuum. They do things at a vacuum, so the boiling point is lower than you would expect. Okay, well, a simple reason is, at a lower boiling point, the taste isn't affected. Because what changes the taste of the food is the temperature, not whether it's boiling. Okay, it could be boiling, if it's not at the high temperature, the temperature is what affects the taste. So a simple reason to do it is, that's not the only reason, but a simple reason is, if you keep it at a vacuum, you get the food to get cooked, or you get it to be pasteurized, whatever you're trying to do, without affecting the taste in the same way. So, here's an example of what they would do it. Have grape juice, and you want to concentrate the grape juice. Concentrating juice means basically, you're boiling the water out of it. So, you want to boil the water out of it so you can have concentrated grape juice, but, you don't want to ruin the taste of it. So what you do is, you put the grape juice into a vacuum, you create a vacuum, and now the grape juice will boil at less than 212. The water will boil out of the grape juice at less than 212 degrees. I stood at a place, they were boiling grape juice, it was bubbling away, it looked like boiling grape juice. When you touched the machine that it was in, it was cold. It was 70 degrees. Because you put the right amount of vacuum, it will boil at anything. It can boil up down to 32 degrees, really, if you went as a full vacuum. This was, if I remember, it was like 70. Okay? So what happens if we're boiling the water out of grape juice is treif. The grape juice is stagnating. We're boiling out at a temperature that's not hot. Do we need to kosher that pot now afterwards? After we finish, they need to kosher that before they make apple juice, which is kosher? What happens in a different case? What happens if they didn't make such a dramatic vacuum? They made a smaller vacuum and it boiled at 150 degrees. Okay? So it was hot, but it wasn't really hot. So now, how should we kosher now? Should we kosher at 150 degrees? Should we kosher at 212? What happens if it became treif at 150 degrees, but I make a real strong vacuum and now it bubbles and it boils at 70 degrees? Did I kosher my pot now? Okay, which one is it? Which one is it? What do I have to do? Am I trying to look for a temperature or the bubbles? Okay, it talks about when kosher you have to get it to bubble. Okay, but here I'm tricking it into bubbling at a funny temperatures. Okay, so which one is it? I'm not going to tell you. It's a question. Okay, I have another question. Yes.
Well, so are you able to make beer would you be able to use that process to make beer in under 18 minutes?
To make beer in under 18 minutes?
I'm saying,
you want to make it to ferment?
You were to do that.
Okay, well, beer, what makes beer ferment is not the temperature. So, well, it needs time just to ferment. I don't think it would have.
Is there a method like that? Is there a method like that that you'd be able to do it under 2 minutes?
Nothing comes to mind, but hey, you never know. Okay, next. Okay, when you know salt, one of the common ways that they get salt is from salt mines. Okay, that means it's in the ground. There are deposits of zillions of pounds of salt. Okay, and it's deep down in the ground. So how do you get it out? So you could go down there and scoop it out and put it into a little train and bring it up. You could do that if you wanted to, but they have an easier way to do it. They fill up the thing with water. The salt gets diluted into the water, and then they pump the water back up. Okay, you just put a long hose down there to pump it out. So you fill it up with water. It gets a lot of salt gets absorbed into it. You pump it up. Okay, and then you can keep doing it again and again. Every time you put in more water, more salt will get absorbed. Okay, well now we have this really salty water. So we got to then boil the water out to get back to having salt. Okay, people don't want salt water, they want salt. Okay, so they boil it out. Okay, so now we boiled it out in a vacuum, which is in fact a very common way to do it. They boil it out in a vacuum. So now, is that salt considered cooked or not cooked for Hilchos Shabbos? On Shabbos, something that was already cooked can't be cooked again. So was this salt cooked or was not cooked? It was put into this vat. It was cooked up, but it was cold. Or it was cooked, it was 110 degrees, it was 100 degrees, it wasn't hot. So is that mevushal on Shabbos that you could now cook it again? Or do you say, no, it's not cooked. It's like someone just scooped it out of the ground and it wasn't hot at all. Yes?
If you had a way of pressurizing it on Shabbos, would be on Shabbos, would you be allowed to do it to begin with that?
To do what? Get the salt out?
No, on Shabbos, like to do it the first process. Basically,
The
boil
process
water.
of boiling the water out of it?
Like, and
That's a good question. I'm not sure. That's not relevant to me because I don't have any Jewish companies who want to do that. Okay? They're not Jews, they can use things sometimes. I want to think about it afterwards. I got the salt in my hand. The salt in your house, good chance that's how the salt was made. Okay? So is that salt considered cooked for Shabbos or is it not cooked? Okay, the last case. A company made chicken soup and they Pasteurized means you cook something to a high temperature so that it won't spoil, essentially. They pasteurize it at 295 degrees. It's not unusual. 285, 295 degrees. It's not unusual to do it like that.
Don't they usually pasteurize that at like 165?
Yes, that's regular pasteurization. Very good. But pasteurization for have you ever seen boxes of drinks or foods that don't have to be in the refrigerator? Okay, those are pasteurized usually at 285, 295 degrees. And because they had a better pasteurization, that's why they don't have to be in the fridge, like a soy milk you have, or a drink, or chicken soup. You never bought it because they don't make kosher chicken soup like that, but they make treif chicken soup like that. So, okay, maybe someone does. So they made treif chicken soup at 295 degrees. Now, how can they boil something at 295 degrees? It didn't just all boil out. It boils at 212. The answer is, what do? They put on the pressure. Okay, they put it on the pressure, and therefore it could, at 295 degrees, it is not boiling. There's no bubbles coming out of it. Okay, and they want that because they don't want to lose their chicken soup. Okay, so they did it at 295 degrees. Okay, and we're done. Chicken soup is gone, and now we want to make kosher food on that same machine. What temperature do you want to kosher your machine at? You want to kosher it at 295 degrees? What?
Probably a higher temperature than the bleach.
So you say we have to do it at a high
That
295?
was probably just a way of describing it, because in the traditional description, then I would describe it as full bubbles.
Right.
I have a way to measure the temperature.
So you're saying since we measure it, we got to 295, we have to kosher it over 295.
You're making one of the math here.
Right. So we have to. I asked you a few minutes ago what the other direction. So you say the other way also. If it became treif at 100 degrees, then I should do 100 degrees. Whatever temperature it is, it would match the temperature. Okay. So This is a question, so I won't tell you the answer to any of these questions. Okay. But these ones. The earlier ones had some chemistry, biology. This one is just physics. We have these unusual properties and ways that we could do it. Again, in industry, this is somehow more efficient. So those are some questions. Okay, I'm finished, and it's about to be recess. If people want to stay, they can stay, and I'll answer questions. Or you can go out and play recess. I definitely would never want to take kids away from having recess. That's for sure. So I wouldn't want to do that. Yes.
Shouldn't you do both pressure and the heat?
Yeah. What?
I'm not sure.
So you're saying is we should do both. He says get me over 295. You say make sure it boils. Because at 295 I can make it not boil also. So you say do both. So you're hedging your bets. But the question is the truth, which is really it. You're saying is I don't know, so I'll just go both. I'll be safe. That might be the right answer if we can't come to the right answer. But the question is, can we find the right answer? Is there a truth to which one we have to? If we don't know, right, we're going to be stuck. Make it 295 and make it bubbles, and everyone will be.
Bleas aren't going in from the boiling. The bleas are going in from the temperature.
Okay, so you say that's what you say. He argues, dude, we need the temperature. I don't care if there's any bubbles at all. Give me my temperature. Okay, go ahead.
What is the answer?
I can only tell you half the answer. The rest of it is too complicated. But for half the answer, I can tell you. Okay, and the half answer you can know is as follows. Think for a second. Let's say somebody made French fries, okay, in your pot. And the fries themselves were kosher, but they fried them in treif oil, okay? How would you kosher your pot? What would you do? You would get it clean, wait for 24 hours, and then dunk it into a bigger pot of boiling water. Well, what temperature were the French fries cooking at? French fries are cooking at 350 degrees. Because water boils at 212, but oil boils at way higher temperatures. So the boiling of those French fries wasn't at 212 degrees. The French fries were way hotter than 212 degrees. Okay, but you could still kosher. And the reason is because the Beis Yosef says there's a maximum. Okay, the maximum we have to do is roasting of water. Boiling in his case means 212, of water, that's the max. You never have to go higher than that, even though it became treif at higher than that, which happens all the time. Okay, every time you put something with oil, it's way hotter than 212. Once you get boiling water, for the cases where Hagala works, where water koshering works, you hit the max. You're done. You don't have to go higher than that. Now, whether you have to get bubbles or not, that's not for today. But that answer is, we know that you don't have to get higher than the 212 boiling temperature. Whether you need bubbles or not, also for a different day. Okay, anybody else? Yes.
It's not so like the chemistry, but coffee. I listened to your share on coffee, and you said that sometimes the problem is because sometimes they will mix the knives they use to cut the food, they'll wash in the same sink as the actual coffee machine.
I don't remember saying that. Go ahead. So tell me your question. Go ahead. Tell me your question.
When was the shear?
Tell me the question.
2010.
Oh gosh. Okay.
2010.
Go ahead. Tell me what the
Point
question
being
is.
is like originally that like Starbucks, all that's ways to get the food prepared. They get the food prepared.
You talking about in a place like a Starbucks. Got it. Okay. Yes.
Yeah.
They wash. Okay, guys. They wash the equipment that they make the coffee with in the same machines or the same sink that they wash knives that are tray for. Yes. Got it. That I might have said. Yes. Go ahead.
Okay. So the question is the Misa today, like what exactly, you don't want to give such terms, are you able to go into Starbucks and get a coffee?
Okay. So the CRC's got a long list of things that you can and can't buy in Starbucks. The question is which ones do or don't have mixing of. What do you say? Yeah. So often they update it. Of which things you can and can't.
Expired at the end of last year. I couldn't find it this year.
Really? So try again. I mean, as far as I know, it's updated. I know that every once in a while they do look it over and change it up, and or if there's no changes, then just change the date on this. People should know. But there's a list of which things they think there's a concern that they'll mix and mix, which is not. Okay. Anybody else?
What exactly is the story with how to like triangle K, for example? How does it work that I want like they're saying it's kosher? Triangle like they're saying it's kosher, it's not kosher. How exactly does that work?
Okay, it's a very long that we don't have enough time for that. No, it's a completely different topic, and that is not every person who knows how to write the word kosher necessarily is up to the standard that you expect in your house. Okay, that's a short answer. So whether a specific hechsher does or doesn't, it's a little complicated. I can explain to you in more detail what could be lacking in a hechsher that other than if I say it's kosher, why wouldn't you believe me that it's kosher? So we could talk about that once. There's a little of its own long discussion, But the short version is, just because I can say it's kosher doesn't mean that doesn't mean that I'm up to the standard that regular people want to eat. People eat kosher. Okay, good guys. Looks like you're off to recess.